Hi there, welcome to the third video in for the calculus topic, looking at integrating ax plus b to the power n, essentially going backwards with using the chain rule, so reversing the chain rule process to integrate rather than differentiate. We're also going to have a look at a couple of trig things as well at the end. Okay, so I'm going to just flip over the success criteria now, just because again it's a kind of instruction of how to do it. Okay, so when we were differentiating brackets of this form, you need to remember those two steps. Firstly, we had to differentiate the bracket, ignoring what was inside it, and then we went on to multiply by the differential of what's inside the bracket as well. Okay, so to reverse this process, this time we're going to integrate the bracket, ignoring what's inside, but then we're going to divide by the differential of what's inside the bracket. Okay, just to cancel out this multiply up here. Okay, so a little trick in that there is a differentiation as part of your integration here, but it's simply to cancel out that multiply. So two things we need to do to integrate when you have something of this form: integrate the bracket, ignoring what's inside, and then divide by the differential of what's inside the bracket. Okay, so two examples here. I'm just going to go into a different slide to give myself a bit more room. Okay, firstly, we're going to ignore what's inside the bracket here and integrate ignoring that. Okay, so that 4 is going to become a 5, and then you're dividing by your new power. Okay, just like you would integrate normally. The other thing we need to do is go back inside the bracket and differentiate what's there and divide by that differential. So in this case, the differential is just 2, so we're going to have an extra factor of 2 on the bottom here, and it's going to be plus c, obviously, because there's no limits. Okay, so that becomes 2x plus 3 to the power 5 divided by 10 plus c. Okay, simple as that. Okay, b here, we need to rearrange it first. So first thing, notice I'm not integrated yet, so my integral's still there. Is given that in terms of a power and on the top line. So it's negative a half there as your power. Then ignore your bracket, ignore that 3x minus 7 just now, and integrate. So minus a half becomes a half, and then you're dividing by a half there. Okay, you then go back into your bracket, differentiate, which will just give you a 3, and you're dividing by that 3, so there's an extra factor of 3 on your bottom line, and that's plus c. Okay, now that becomes 3x minus 7 to the power of half over 3 halves plus c. And then when you're dividing by 3 halves, remember you're just times by 2/3. So it'll be 2 times that bracket square rooted over 3 plus c. Okay, job done. So another one here, just slightly different with your integral here, just because of the limits. Okay, so again, in order to integrate this, we need to rewrite it in terms of powers rather than rationals. So 2x plus 1 to the power of a half with respect to x. I'm ready to integrate now, so I don't have this integral anymore. Ignore the bracket is not going to change. Oh, I don't know what happened there. Okay, it then becomes 3 halves divided by 3 halves. Okay, and then go back into your bracket and differentiate. That gives you a 2, so we're going to times by 2 there. And all of that is between the limits of 0 and 4. I'm just going to tidy up a little bit just before I start. Okay, so it will be the square root of 2x plus 1 all cubed over 3 halves times 2 is just going to be 3 between 4 and 0. And then I'm ready to put my limits in. Okay, I'm just going to shift up here. So it's the square root of 2 4s plus 1. I'm just going to put a bracket around there. Cubed over 3. Take away the same. Two zeros, add 1 cubed over 3. Okay, 2 4s are 8, add 1's 9, square root of 9 is 3, cubed is 27, divided by 3 is 9, and then that's just 9 take away a third. Okay, so 27 thirds take away a third is 26 over 3. Okay, so nothing's changing here. The only thing we're putting in is a slightly different way of integrating because there's a bracket there. Okay, and last thing we're going to look at, okay, a couple of trig examples. Okay, so same thing again. Okay, we're going to ignore the bracket. So that sign, we're going to ignore the factor of 3x minus 1 here and just integrate the sign of something. Okay, now we know when we're integrating sign, and there's a tip on the formula sheet for you. It's a negative cos of the same bracket. You're then going to go, that's not a 2x, it should be a 3x. We're then going to go back in and differentiate the 3x minus 1. So it's all divided by 3. Okay, and then your plus c. Okay, and here, the bracket, remember, around that 2x. So we're going to integrate it first of all. We're happy to go. So it becomes sine of 2x. Go back into the bracket, differentiate, and divide by that differential. Okay, so that's pi over 2 to 0. Okay, good to put the thing in. So it's sine of 2 times pi over 2 over 2, subtract sine of 2 zeros over 2. Okay, so 2 lots of pi over 2 is just pi, is 180. Okay, so sine of 180, we know is 0. Okay, so that's just going to be a 0, and then sine of 0 is also 0, so this whole thing is going to just be 0. Okay, so going back to learn tension success criteria, I want to be able to integrate the function ignoring the bracket, divide by differential of what's inside the bracket, and then complete any simplification there as well. Okay, fourth one again, just like your trig one, is working specifically with trig terms as well. Okay, thank you very much.